Idea of our engine, our first engine. It's actually a prototype number 2, and then we show two different types of air compressors here. One's an oil-based air compressor, oiled actually in the airstream, and the other is oilless. So what were we trying to do? A lot of people have no idea, but the cars that you drive right now today that have piston engines in them, they're only 30 to best case 40% efficient. That means that 60 to 70% of all the energy that you're burning with that, gasoline or diesel fuel or whatever is actually being used to move the vehicle. The rest is just being wasted as heat, either in the oil, in the coolant, etc. So they're terribly inefficient. The other thing that's key about the engines today is, and there's various types, it's not only the piston engine, but they're about 150 years old on the architecture. Had a lot of work put into them, but the things that improved efficiency have just been bolted on systems, not necessarily a change in the base architecture. So what we try to do is we focused on how can we improve that and then also get to a perfectly clean fuel. So we looked at removing as much reciprocating weight as possible, and that's the weight that slings around and is unbalanced inside an engine. And if you can get that reciprocating weight out, then you can dramatically improve efficiency and convert more of that combustion into motion instead of getting it into heat. And the technology we have basically allows us to convert that pressure to kinetic energy much more efficiently. And we can basically replace any standard engine or compressor or pump that is out there. We can use it in all sorts of different industries, everything we say from a lawnmower to a cruise ship, although we're not going to focus on the lawnmower industry. It's cutthroat, there's not much profit there. But also, a lot of people think, what about electric vehicles? Why are you even working on a combustion engine? They're going away. I think the public's quite bamboozled relative to the complete carbon footprint of electric vehicles. If you look at the mining and all of the issues that are created way up front, you look at the power generation not being all, at this point, sustainable. You still have a lot of coal, a lot of natural gas creating that electricity, and then you have huge recycling issues at the end to get rid of those nasty batteries that have horrible chemicals in it. And I used to run a battery manufacturing plant in South America, and the energy that goes into making those batteries and the pollution created to do that is immense. So don't be completely bamboozled as the public that they're so great. You only think about, oh, I'm plugging it in, but you're missing all the other aspects to it. So our end game is to get to fuels, and we can run on common fuels today like gasoline or diesel, semi-clean fuels like propane or natural gas, but our end game is to run and combust off of hydrogen or Brown's gas. Basically, you put water in the tank, and you would end up running your vehicle off of water and generate the oxygen and hydrogen as you need it from that water. That's our end game. That isn't where we're going to start, but that's our end game where we're headed. Basically, our mission is to transform the energy creation market and the mobility market to improve the world's carbon footprint, reduce natural resource consumption, and to create a lot of great jobs. So I mentioned our brand name is called Dynakinetic. Our company, once again, is GoTek Energy. We're basically looking to take a lot of that piston power, convert it to dynakinetic power, to go from fossil fuels to clean, semi-clean fuels to perfectly clean fuels like hydrogen. And that's just a little phrase. We take the fossils out of fuel, we take the fossils out of the air, we're going to make fuel out of water. So what do we do? Steve, who's with me, he's actually our CEO, he came up with a very brilliant idea when I first met him. And he basically knew that there are three fundamental types of engines today. You've got turbines, which are very complex to machine. They are extremely expensive as a result. You see all those spins and etc. There is only one moving part, which is great, but it's got to turn at very high RPM, and it's got an open combustion chamber. So if you tried to put that in some mobility applications like a car, which they did back in the 60s, you could burn the paint right off of, excuse me, that's me, you could burn the paint right off of the car behind you. So there's some negatives to that, but it is the most efficient engine out there. Then you've got the piston engine, which once again I mentioned is not very efficient. It's got a lot of moving parts, but it's had a lot of development poured into it over 150 years. Then you have the Mazda engine, or the Wankel engine, in the middle, and it's only got one moving part. It's a closed combustion chamber, but it had three issues that kept it from being successful. It was dramatically small, dramatically light, but it didn't overtake the piston engine. Number one, it's got a horrible combustion chamber, very long, pinched off in the middle. You just see those two little slits. Even had to put two spark plugs in it to ignite it. It's got very poor torque, because it's the distance from the center of this to the distance of that triangle. It's only about a half an inch. There's no leverage that you get out of it when you combust. That's why it was only put in lightweight sports cars. And never in a heavy-duty truck. It wouldn't work. It didn't have enough torque to move the weight. So Steve focused on taking the best of all three of those and coming up with a new rotary engine, because it had the biggest room for improvement and it got most of the reciprocating weight out with that sort of architecture. So this is the fundamental design of the engine we're doing. Once again, it can be back-driven with electric motor and become a compressor or a pump. And so this is sort of the engine block and the head, one unit covering both of those functions. Two plates on the end with stationary sun gears. This power module in the middle that's got all the moving parts, and if you explode it, it's got a rotor, that crankshaft perfectly flat, perfectly straight I mean, and then you've got some mini cranks, a rod, and some pivot pistons which give very good leverage. So you put that all together, that's sort of the architecture, and you've got one chamber doing the intake, one doing the compression, one doing the power stroke where the combustion is happening, and one pushing the exhaust out. The beauty of this is in one revolution you get 4 cycles out of every one of those chambers. In a current piston engine you have to turn it 2 revolutions to get every one of your chambers to go through 4 cycles. It only has 13 moving parts, not 54 or more like a piston engine. It's got one power module here that has all the moving parts, so it really helps with serviceability. And we can extrude most of this instead of cast. And if anybody's ever done anything with casting, there's a lot of complexity in getting rid of sand and all kinds of things after those castings are done. We also only need one injector and one spark plug because the chambers pass by it. If you have an 8-cylinder car today, you ever change your spark plug, you have 8 spark plugs. Even though we have 4 chambers, we don't need 4 spark plugs. We can get by with 1. So a little bit of simulation of how this thing works. I've got to do this from over here. This gives you an idea of the operation of the unit. And what you have is, in this case, you have air coming in here, then it goes by that port, it compresses it, shoots in fuel, sparks, combusts down here, and then turns around and shoves it out. That's a basic operation of the unit, of how it works as an engine. If it's a compressor or a pump, we have an inlet and an outlet, and an inlet and an outlet, and we drive this with an electric motor, and it can compress air, it can compress natural gas, it can move water, it can do any of those things. Some advantages of our technology. This is comparing our technology to a piston engine and to the original Wankel engine. Those blue numbers give you an idea of improvement over a piston engine. So we're basically 42% more efficient, 68% less in weight, 76% less moving parts, 52% less reciprocating weight inside, and 53% more torque or leverage. Those are some pretty significant numbers when you compare that to the piston. Some of our technology, we've patented all over the world in the key markets. We've got awarded patents for that architecture so far in the US, South Korea, Taiwan, Canada, and China. There's a couple of countries that lag. They all run at their own speed when you patent, so we're still waiting on India and the EU. We also have some enhancing technologies to do variable compression and to do a removable sleeve for serviceability. We've got trademarks on our Dynakinetic name and our GoTek Energy name as well. That gives you an idea of some of the countries, the US, Canada, all the European Union, Brazil, China, India, Japan, South Korea, and Taiwan is where we're patented. That is a huge expense. We're probably in the $600,000 range so far just on patent expenses. Some enhancing technologies then on top of that we're looking at. Plasma ignition, plasma exhaust, that gives us more flexibility to run any kind of fuel that we want in the unit without changing the architecture. We've got variable compression, that also lets you run different sorts of fuel. We can stack units, so you can take one size unit like a 1.5 liter, add another 1.5 liter and get a 3 liter. So it gives you sort of the building block concept. We talked a little bit already about the hydrogen fuel. There's some laser etching that we're going to do on our pistons to avoid wetting from fuel. And then we have some ceramic components in certain areas where high durability requirements are needed. So what does this mean to the end customer? We're a business-to-business business because we sell to businesses that then put our engines or our pumps in their products and go forward. But if we can do more power, more response, that gives our customer, our end customer, exciting performance. If we can lower vibration, increase reliability, that gives you solid durability. If we have different fuel usage, better, we can run on any fuel, and we lower weight significantly, gives us amazing economy. With one moving unit that's got all the moving parts in it, or power module, it makes maintenance very simple, completely eliminates the valve train that you see there on a normal piston engine. And then if we lower emissions and reduce size, it helps with the planet friendliness. So we hit every major area that really matters to the customer, not just a niche area. Some of our competitors, just list some of the new engines that are being worked out there. For the most part, they have a lot of reciprocating weight, which once again doesn't make them that efficient in all areas of operation. And then some are reverse Wankel, which gives them a lot of the problems that the Wankel engine had with seal wear and combustion limitations and etc. And that's why we're not too concerned about these other types of technologies that are out there. The other thing we did is we were pre-revenue, we actually are post-revenue, very early post-revenue now. We designed our manufacturing process in parallel with our product. So we didn't wait till the 23rd hour and think, how are we going to make this? So you can see we have the whole manufacturing line laid out already. The power module gets created on the top section of the cell. The housing gets created here. They come together, and this is where it would be the complete engine, pump, or compressor. And then this dresses it out with accessories if it's an engine, for things like the starter and the alternator and the fuel system and etc. We have one engine coming off, if it's set up for an engine, every 222 seconds an engine pops off. And it's the testing that sets the pace on the manufacturing line. What are the markets that we're looking at? Kind of gives you an idea. We basically, we're talking about a half trillion-dollar market a year when you add up all the different pumps and compressors and engines that are out there. And with two engine sizes, a 1.5 liter and an 8 liter, by stacking them, we cover 60% of the need for engines. We can do two 1.5s and make a 3 liter. We can then do an 8 liter and stack two of them together and get a 16 liter. That lets us cover small cars, large cars, SUVs, medium duty truck, and heavy duty truck with just two engine sizes. The other thing is when you look at our profitability, because of the extreme weight reduction, you use less material. 67% weight reduction means a big savings in material cost. You look at labor costs, we have 76% fewer moving parts. Those are less things to assemble, so we have a dramatic drop down in the labor cost area. Then when you look at your overhead cost, our capital runs about 16% of what a normal engine manufacturing line would run because of the simplicity of that design. That means we can be very profitable with this.
Scott, about 5 minutes.
5 minutes, sure. Gives you an idea of some of the customers that we have. We've had most all of our customers come to us. Our problem is not customers. They're seeking us out. We didn't have to go out and spend really any money to seek them out. So we have a major air compressing company, a genset company that's regional. I can talk about Bell Helicopter. They gave us permission. They came to us for unmanned heavy lift drones to use our units because they have so much torque and they're so light. We also have a confidential global automotive OEM where we had a vice chairman of an automotive company and his whole staff spent 3 days with us. And they ended up executing a memorandum of understanding with us, and we have a heavy-duty truck manufacturer as well that's got interest. Just a couple highlights. The air compressor company came to us because they were really excited about the high flow and the low energy consumption of the units. Our Bell helicopter, they came to us because they were excited about the power to weight and size, as well as the operating speed and the torque of our engine. And they are working with companies like Uber to ultimately do lifting of people and to take them from one spot to another, and we're part of that plan. We also have some strategic partners, a company that's in the area as well that was working on some new engines and gensets that tie in with us because we need both of those. Lawrence Livermore Labs saw our patent issue and they came to us as well and wanted to go after a DOE grant, and I'll highlight that here in the next slide. When they did some research after they saw our patent issue, they said, we think you're the first engine we've seen that can efficiently combust on hydrogen and be perfectly clean. Let's apply for a DOE grant. We did that, we won the grant, and we're in the process of producing an engine for them now, and we'll be doing testing up at their labs to see how that pans out. The way we launched as a startup company is we teamed up with mid-cap companies in the area. And we did in-kind trade-off instead of cash. We were in Willis Machine. That gave us free capital. I should say free, we had to give up equity for it, but it didn't create a cash outflow. So we have people, we have capital, we have floor space, and we paid nothing other than gave away some equity, and we exist in their facility. We have another person on our board that's out of China, and he can do ignition, and he has a China footprint. We have a street sweeping company that gives us a fleet to test units on. We have 2 race teams that give us racetrack access and dyno access. We have a major seal supplier that supplies really seals for all the racing industry, so they're experts in those metallic seals. We have a military contractor that gives us inroad in the military, and we've got JD Power & Associates, which most of you know, that's one of our early investors. This is a quote from them on why they invested in us, is they really saw our engine being very simple, and as a result, having a better chance of having high quality. We also have this race team that I wanted to highlight. They are so well respected. They actually worked with Mazda, Nissan, then raced for Maserati, and they're now heading up all the race teams' efforts for McLaren. So very well respected, and they give us advice as well on our engine design. This is the team, and then I'll be wrapped up. So Steve is the founder, and he's got a lot of experience with serial entrepreneurship. Myself, I really came out of the Fortune 100 industry, so I'm used to launching huge factories and facilities all over the world and running technical centers. Lydia is very good with HR and strategic marketing. Brian is our finance person, and he's got a lot of experience with all the Sarbanes-Oxley and military and etc. And then we've got Jimmy, which is located most of the time in China, which gives us great access to some of the supply chain there as well as customers. But our footprint is not to go to China and manufacture everything. It's to manufacture in the region of use. So if we're going to sell in Brazil, we'll be having a facility in Brazil. Sell in China, we'll be there. Sell in the US, we'll be here. And that's it, unless there are any questions. Yes?
Where are you located?
We are in Oxnard. We do a lot of our design up in Ojai area, and then we're in Willis Machine right now in Oxnard. Once our large funding arrives, then we'll be setting up our own separate facility. And we've got a lot of stuff in the works there, but I can tell you it's not for the faint of heart to round up funding for hardware, because it isn't the flavor of the day. Most of the funding from venture capital is going into software, which is unfortunate. At the end of the day, software has to run on hardware. So we look at a lot of other routes, and the routes we're taking are to team up with strategics who are our customers. They bring in the funding, we bring in the intellectual property, and we'll set up joint ventures. That's our business model.
Bill?
What are your emissions like?
We're not going to say that yet until we run our pilot unit. We've got 2 levels of prototypes we went through. And right now we have parts coming in for pilot engine units, and once we get those through test, then we'll put all that information up on our website and advertise where we're at. But we have no reason to expect it's not going to be better than piston engines. I'll say that.
We're going to have to wrap up, but Scott, can you stay a little bit at the meeting? So if there are other questions, please answer. Thank you. That was really informative.